In this video, we're breaking down what's really behind ChatGPT, Claude, and all these AI tools. It's not magic, it's something called an LLM or a large language model. And by the end of this video, you'll understand what that means in simple terms and how you can start using one yourself. Alice Zhao here from Maven Analytics, and in this video, we'll be covering these 8 concepts, starting with the basics of neural networks, deep learning, and deep learning architectures. Then we'll move on to transformers, LLMs, and Gen AI, which are behind the most powerful models at the moment. And then finally, we'll talk about how to use LLMs within Python and additional tasks like fine-tuning and RAGs. Now let's dive in. First up, neural networks. Here's what a basic neural network looks like. You feed in some data on the left, and it makes a prediction on the right. And each of these circles here is called a node. And at each node, the inputs are multiplied by weights and then added up. And then that's passed through something called an activation function. And that just means the input is mapped to another value. That output then becomes the input for the next layer and so on. Now, neural networks are able to extract and learn patterns from data, such as the sentiment or the positivity or negativity of your text. Next, let's talk about deep learning. If you take a look at this visual, this first part is called an input layer, and this last part is called an output layer. And then the middle ones here are hidden layers. And deep learning is just a neural network with more hidden layers. And these extra layers here allow the model to learn more complex patterns, like the grammar or tone in a sentence. Now let's move on to deep learning architectures. This is where you combine the deep learning structure with other calculations. Popular architectures include CNNs, which are used for images. In addition to deep learning, they also have steps to extract edges or textures from images. RNNs and LSTMs are used for sequences, and they take the prediction from one step and feed it back into the next one. And while RNNs and LSTMs used to be used for text data, they have now been replaced by a faster and better performing architecture called a transformer. Hey there, if you're enjoying this video, just so you know, the content is actually a part of my full 22-hour NLP and Python course at Maven Analytics. So if you want more hands-on practice and full-length lessons, check out the link in the description below. All right, now let's get back to the tutorial. Transformers have completely changed the natural language processing space. This is the architecture behind ChatGPT, Claude, and all the other AI text tools out there. And this idea came out in 2017, and it's built on 3 main parts. The first part is the embeddings layer. And this is where words turn into locations in space. And those locations in space have some meaning. So words that have similar meaning will be close to one another, and words that are different will be far apart. Next is the attention layer, and this is the step that looks at context. So in the sentence, I love cold lemonade, the word cold modifies lemonade, or in other words, it attends to lemonade, or it changes the meaning of lemonade to actually be cold lemonade. And then what happens mathematically is the location of that lemonade embedding in space gets slightly modified based on that cold word, and that's how lemonade can absorb the context of the words around it. This idea, again, is called attention. And then finally, you have the neural network layer. And this again is the learning step. This takes the output from the attention layer, and then it learns deeper relationships like adjective-noun pairs or sentence structures. Now these steps happen again and again, hundreds and thousands of times across many layers, which is how transformers pick up the complex patterns within language. Now once again, transformers are what's behind text generation, summarization, translation, and so much more. Now that you have the foundations down, let's talk about large language models, or LLMs. These are models like GPT that have been trained on millions of rows of data using deep learning architectures such as transformers. So what do I mean by trained? It means that someone, typically a large tech company, has chosen a deep learning architecture, and then they input and label data. So given this word as an input, this is the next word, and then the model settles on a set of weights or parameters. If you remember back to our original neural network visualization, every line going into every node had a weight or parameter assigned to it. And then when a user wants to use the model, they don't have to do any of the complex training steps. All they have to do is enter in an input, such as a sentence, then it's passed through all the model's calculations. Remember, there were those weighted sums and activation functions at each node, and then a prediction is made at the very end, such as the next word that should come in the sentence. So to summarize, large stands for the large amount of data that a model is trained on. Language tells us it's trained on text data, because technically, these models can be used for other types of data, like images or audio. And then finally, model tells us it's a deep learning model. There are so many LLMs out there, But at the end of the day, they all fall into just 3 categories. Encoder-only models are used for understanding text. So you give a sentence and it outputs the meaning of the text in an embedding or vector form. And then you can take that vector and use it for downstream tasks like text classification. And BERT by Google is a popular encoder-only model. Then you have decoder-only models, and these are used to generate text. So you can give it a prompt and they predict one word at a time. GPT models like ChatGPT by OpenAI all fall into this group. And when we talk about Gen AI or generative AI, where AI creates new content, decoder-only models are what's used to create new text content. And third, you have encoder-decoder models, which are used to both understand and generate text. And these are used for things like translation or summarization. An example of this is the T5 model, which again was created by Google. And the common thread here is that all of these use the transformers architecture, but they're all structured slightly differently based on what task you're trying to accomplish. Now, how can you use LLMs in Python? The most popular and beginner-friendly way is with Hugging Face. They have a model hub with millions of pre-trained LLMs, and with just a few lines of Python code, you can use them on your own text data. You just have to specify what task you want to do, such as sentiment analysis or zero-shot classification, and then you can leverage the pre-trained models built by large tech companies on your own dataset. Under the hood, the Hugging Face Transformers library is connected to PyTorch or TensorFlow. But for the most part, Hugging Face's Transformers library will get you 80% to where you want to be, and if you want to create custom models, then you can do deeper dives with either PyTorch or TensorFlow. Finally, if you don't want to use a pre-trained model as is, you can incorporate your own data as well using fine-tuning or RAGs. Now, the idea of fine-tuning means adjusting your model's weights. So if you remember back to our pre-trained model, all the lines from node to node had a weight associated with it. And when a model is pre-trained, those weights are locked in. And with fine-tuning, you can feed in your own data sets and start adjusting those weight values based on your particular data set. Now, another option is RAGs, or Retrieval Augmented Generation. And this is where you can combine a pre-trained model with an external database of text, such as your company's wiki or PDFs, and combined, they can generate better answers. Okay, that is your crash course in LLMs. In just a short amount of time, we've covered these 8 concepts here. LLMs have completely revolutionized the way we work with text data, and they've caused a huge mindset shift for data scientists. Instead of coding from scratch, we can now leverage these pre-trained models for our own text data, and they work surprisingly well. If you've enjoyed this crash course and want to learn more, you can check out my full 22-hour course on natural language processing in Python, where we go through all these concepts in a lot more detail and work through hands-on exercises as well. Again, my name is Alice Chow, and as always, make sure to like and subscribe to get more data content just like this. I'll see you in the next one.